Currently, microservices are all the rage. They're so popular, in fact, that people now want to stop using them and go back to monoliths. And this is because microservices bring with them a lot of chaos. They enable you to decouple stuff and have different teams focus on different topics, but they're also really hard to debug and follow. One of the great solutions is event-driven architecture. In event-driven architecture, we have a publisher and a consumer, or also called pub/sub, publisher subscriber. The crucial part here is that the publisher can publish an event to a bus and then forget about the event. The publisher does not need to care if the event arrives, it just publishes it. The consumer can then see if there's any interesting events that are in the bus and consume them. With this, you achieve a decoupling of your services if they talk via an event-driven architecture instead than over a REST API or over gRPC. Because with those, they're directly coupled. And if you make a change, you basically can't do this, and so you're dependent on the other service. So the event-driven architecture allows technical independence for the microservices, which is what the whole purpose of microservices basically is. And you can see that especially for bigger systems where there is maybe a smartphone app or a point of sale service system, they can all emit different events, and then these can be consumed as needed. In my company, not only do we have microservices, but also we are now moving to a domain-driven design where there's different domains that take care of stuff, like user acquisition is one such domain. So for us, the event-driven architecture can be really useful, and we decided to go with AWS's EventBridge. This is because this is easy to set up, get started with, and has useful plugins, for example, with Salesforce. We decided to go really simple. So we only have one bus, and to this bus then you can publish events, and in this AWS EventBridge you can attach rules to the bus also. And basically when you publish to a bus, you can, in the event that you publish, you have to specify a detail type, which is basically the event name, and a source, which you can freely decide on. And the consumer then has to use this pattern to get your events, because the consumer basically is a rule which is filtering the events in this bus. The bus is basically like a river full of events, and the rule has then this pattern. You can see it here: renovation plan received for the name of the event and user acquisition for the source, which is the domain. And then as a target, whenever it finds this event floating around, it will send it to SQSQ, which then again can be consumed in a service. You quickly run into the problem that you have all these different event schemas floating around, and also that you want an event and you don't know if this event already exists. So basically you need some sort of documentation. Here a very popular choice is Async API. And Async API is basically a YAML file, and in this YAML file, you can write your specification about the event, who subscribes to it, who consumes it, and so on and so forth. And it will then you will then be able to convert these into documentation or even code. The challenge is that this is all about the source of truth. And here the documentation becomes the source of truth, and this brings some obvious problems like drift when the documentation and the reality doesn't match up anymore and has to be updated, but this update doesn't happen maybe, or happens too slowly. Because the actual source of the truth basically is whoever publishes the event in the code and whatever payload they decide to send, and so on and so forth. Because even Async API doesn't allow runtime code bindings or code checks where it checks if the event that you're publishing is valid. AWS has this feature called Event Discovery. You can turn it on, and then in the schema registry, so it also has a schema registry, there will be a discovered schemas section, and it will automatically discover all the events and their schemas that you send and recognize if something belongs to the same schema or not. And then they land in this registry, and Then there's a different documentation tool called Event Catalog. And with Event Catalog, you can add documentation, but it also has integrations with Async API and the schema registry. So you can just pull all the schemas from here. You can pull them. You can then also add documentation to them. And the problem with Async API here again, this Async API is an integration also for Event Catalog. So that would be nice, right? If instead of the event registry, we use Async API. But Async API is updating their stuff, and only the version of 2.66 is compatible with the Event Catalog. But now Async API made a major update, 3.0, where even they updated the specifications, so the way you write the YAMLs, so it's not compatible anymore. This is also a drawback with Event Catalog because it is run by a single developer, props to that guy. However, it is a bit unstable and buggy, and there's not like a great community support as you would expect from other major libraries or tools. And with that, I hope you found this video interesting and that it helped you. We covered a lot from how to design the event-driven architecture to documenting it. Leave a comment if you found it interesting and how you would design the event-driven architecture, and have a great day. Bye.